In this lesson, we're going to look at maximum and minimum values of a function. We want to develop an algorithm or a series of steps that will help us identify minimum and maximum values for any particular function. So looking at this example, we want to identify the maximum and minimum values from this interval. So our interval here is going to be -2 and to 4. So -2 and 4 is here. So we're looking really just at this range here. And now looking at it graphically, it's not a big deal. You can you kind of know, you're like, Miss Weiss, of course, is going to be, your maximum is going to be at -115, and your minimum is going to be at 3, what is that, -17. And so not a big deal to figure it out graphically. But how are we going to figure this out algebraically if we didn't have the graph to work with? So what can we determine about these points, these max and min points? So looking at, if we think about the derivative, let's just think about what's happening. So as it's going up and we're increasing, the derivative here is really high positive because the slope's really high positive. And then it's kind of slowing down, it's decreasing until it reaches this point. At this turning point right here, we have a flat slope. So the slope here is actually 0 because we know that any constant or any flat slope, and this line right here is just y equals 15, and the slope is just going to be 0 because you know the derivative of 15 is 0. So that's key. And then here it's just going to increase again in the negative direction, right, because it's becoming more negative. It's highest here, and the same thing's happening here. It's going to decrease until it gets back to 0 at our minimum. So when the derivative, if we set it to 0, we could probably identify a max or a min. We might not know if it's a max or a min, but at least we'll know where the maxes and mins are. Now let's look at the situation algebraically. So this is the function that was graphed before, and we're talking about how when the derivative is equal to 0, we have a max or a min. So let's take the derivative and set it to 0. So here the derivative would be 3x squared minus 6x minus 9 plus 0, right? And now let's set it to 0. So we're left with that, which looks like, let's just factor out the 3 because you can see that right away. And so now it's much easier to factor. So two numbers that multiply to -3 add up to 1, or add up to -2, and those numbers are x minus 3 and x plus 1. And so we can figure out what our values are. So here, x is, so you just divide out this 3, get rid of that. So we have x is equal to 3 here, and here x is equal to -1. So we're going to refer to these as our critical points. So we know it's either a max or a min or something important where the derivative is equal to 0. And so now let's check if it's within the range. We know that both x equals 3 and x equals -1 are between -2 and 4, so we can use these for our max and min. So now what we would do is sub x equals 3 and x equals -1 into your original function, f of x, and then your highest value is obviously going to be your max, and your lowest value is going to be your min. So when you're left with these two numbers and you're not really sure what a max or a min is, the obvious thing would be to just plug it in and then see which one's higher, which one's lower. So now let's look at this example. I've taken the liberty to identify our interval, and so it's between -3 and 10. And we can automatically see if we decide to take the derivative, set it to 0, that's going to give us these 2 points right here. So here, f prime of x is equal to 0, as well as here. So those will give us something called local max or mins, but, and this is definitely a min, but I'm not sure if this is a max, because this point right here is much higher. So I would say this would be your maximum value, even though it's not a turning point. And this point right here is going to be a local maximum, but not an absolute maximum. So in this case, our maximum occurred at a point other than where f prime of x was equal to 0. So we need to develop, just refine our algorithm on how we're going to approach this. So to test for our maximum or minimum value, we want to first find the derivative, set it to 0, and that would give us any critical points that we may have, so any maximums or minimums. And then we want to determine what the y value is at those critical points. And so let's call our critical point C. We're going to determine f of C. And then we want to look at the endpoints, because just like in the case above, your endpoints might be higher than your critical points or lower than your critical points. So we want to determine f of x at our interval endpoints. And then we want to compare f of c and f of x at interval endpoints. And then obviously the highest value is going to be your max, and your lowest number is going to be your min. We can also have a situation like this, where our interval here is from -5 to 10. And then just looking at this, we see that our critical points are here and here, and our max and min values are actually both our endpoints. So this can happen too. So just to summarize, our maximum value can occur at a peak, or when you set the derivative equal to 0 and find that critical point, or at an interval endpoint, as we've seen. So those are the two situations. And similarly, a minimum value can occur at a valley, or when your f prime of x is equal to 0 at that critical point, or similarly, like we've seen, at an interval endpoint. Okay, so now let's look at this algebraic example where we have f of x is equal to x minus 2 all squared, and our interval here is from 0 to 2. So let's take the derivative, and it's going to be 2x minus 2 times 1, and now set that to 0, so that's just 2x minus 2, and here the 2 is gone, so x is equal to 2. So that is our critical point, which also happens to be our endpoint. So now we want to evaluate our y points at 0. So that's going to be 0 minus 2 squared, which is 4. And obviously at 2, because it's an endpoint and a critical point. So let's check that out, and we're going to get 2 minus 2 squared, which is just 0. And so this is obviously going to be our max, and this is going to be our min. So we're just given two values here, so we can say that our max is at x equals 0, and our min is at x equals 2. Okay, now let's look at this example. So our function here is f of x is equal to x cubed minus 3x squared. This here is just another way to express an interval. So x is an element between -2 and 1. So it means exactly what we've seen. It's just that's our interval. Okay, so take the derivative. That's going to be 3x squared minus 6x. Set it to 0 to find our critical points. So I'm just going to factor this. And so we can say that here x is equal to 0, and here x is equal to 2. So now looking at these values, we can, so x equals 0 is within our range, but x equals 2 is not within our interval, so we don't really care about that value. And so we want to check out f of -2, because that is our endpoint, and evaluate that. And it comes out to -20. We want to check out x equals 0, because that's our critical point, and that is going to be 0 if you plug 0 in, and f at 1, because that is our other endpoint, and that's going to be -2. And so looking at our values, we can see that we have our max at 0, and our min is at -20, which is when x is equal to -2. Okay, so for our last example, we have a function f of x is equal to 4x over x squared plus 1, and our interval is between 2 to 4. So take the derivative. We need to use the quotient rule here because there's two functions that are divided by one another. So the f of x is your numerator, g of x is your denominator, and we will get 4 times x squared plus 1, which is your g of x, minus, so f of x is just 4x, and then take the derivative of g of x, which is just 2x, all over g of x squared. So now we want to set it to 0, maybe expand it a little bit, so 4x squared plus 4 minus 8x squared, all over x squared plus 1 squared. Okay, now we can essentially get rid of the denominator because we're multiplying both sides by x squared plus 1. So when we multiply both sides by it, because we want to get rid of it, this is gone. And so we just get 4 minus 4x squared when we collect like terms. And now let's factor that, so it's really just 4, 1 minus x squared. And so you can kind of see that that's a difference of squares. And so that's just going to be 1 minus x, 1 plus x. And so you're going to get two answers here. So x is equal to 1, and x is equal to -1. And so looking back at our interval, both 1 and -1 are not on the interval, and so we can dismiss those critical points. So now the only values we really care about are f of 2, which when we plug that in, we get 4 times 2, 2 squared plus 1, so that just gives us 8 over 5, and f of 4, which is going to be 4 times 4 over 4 squared plus 1, so that's 16 over 17. And so we can say we have a max at 2, and the y value is 8 over 5, and your minimum is at 4 and 16/17. And that's how you find your max and mins.